For this problem, we'll prove that the limit as x approaches 2 of the function 5x plus 20 is 30 using the precise definition of the limit. First, we'll review what the precise definition of the limit is and look at a general strategy for using this definition to prove a limit equation is correct. So here is the precise definition of the meaning of the statement: the limit as x approaches c of f of x is L. For all epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus c is greater than 0 and less than delta, then the absolute value of f of x minus L is less than epsilon. Now, proving a limit using the epsilon delta definition of a limit then can take the following general strategy. First, suppose the absolute value of f of x minus L is less than some epsilon for the values of f of x and L given, and an arbitrarily small value that is positive of epsilon. And number two, use algebraic manipulations to convert the inequality, the absolute value of f of x minus L is less than epsilon, into the absolute value of x minus c is less than some algebraic manipulation of epsilon. And third, if we can accomplish number two, then we just set delta to that algebraic manipulation of epsilon, and we know that whenever the absolute value of x minus c is less than that, then the absolute value of f of x minus L is less than epsilon, and the limit is proven. So, we want to prove that for all epsilon greater than 0, there exists a value delta such that if the absolute value of x minus 2 is greater than 0 and less than delta, then the absolute value of 5x plus 20 minus 30 is less than epsilon. We start by supposing the absolute value of 5x plus 20 minus 30 is less than some arbitrarily small value of epsilon. Now we're going to do some algebraic manipulations to both the left-hand side and the right-hand side until the left-hand side is the absolute value of x minus 2. Okay, we can simplify the plus 20 minus 30 to minus 10. Then we can factor a 5 out of the expression inside the absolute value, and we can factor a positive 5 out of the absolute value. Now we can divide both sides by 5, and now the left-hand side is exactly the absolute value of x minus 2, and the right-hand side is epsilon divided by 5. Now we let delta equal epsilon over 5. Because of our previous algebra work, we know that whenever the absolute value of x minus 2 is less than this delta, the absolute value of 5x plus 20 minus 30 is less than epsilon. For every epsilon, there exists a delta that satisfies the implication, so the limit is proven.